What's up guys, and welcome to my YouTube channel. Following on from my last video, I've decided to do an illustration of how the garden sprayer works and the basic function and mechanics of it. I thought I would do it in a separate video to keep the other one as short as possible. So if you're interested in finding out, then keep watching. Okay guys, so here's your the main workings of this. We're gonna have airflow represented by orange. Pipes here. There's that. Okay, excuse the terrible illustration here, but you should get the gist of it. Okay, so we have our water level here. Water. Never hatch the opposite direction. Never ever do it. It always ends up a mess. So we've got a cavity here that will be filled with water. Inevitably there will be some water, water or an air gap somewhere in this. Not that it really makes much of a difference. So we've got air that gets pulled in around the outside here. So what happens is when that goes up, so we're going to be bouncing between these two here. When your plunger goes up, this O-ring moves down here. And what that allows is air to come around the sides here, through the gap here, because now this O-ring is loose, through the gap and through these two little holes. There's your O-ring. That's the O-ring there. So your air is basically going to come through here, around underneath the O-ring and out through these holes here. And that allows air to get into your cavity. So we're going to start filling up with each plunge. We'll fill up the gap or create a pressurized cavity here, because there'll obviously be air there. We're not in a vacuum. So there'll be water and air. So your air is going to come down through here, around the outside, and into there. Then when your plunger's at the top, as soon as you start moving that down, the pressure formed inside here is going to push your O-ring here back up, so it's going to interface with that face there. And when that interface is there, it creates a seal, which is what allows any air that's trapped underneath the plunger here, so your plunger will be up at the top, any air that's trapped in that cavity here is going to then be forced down and back into your chamber here. So by doing that, every time you plunge, so if you have a narrower plunger, and the same works with pumps, when you have a smaller cavity, you can get higher pressure. When you have a larger cavity, you tend to get lower pressure because more pressure is required to put. So the mechanical advantage is such that when you're pushing a small volume into a bigger cavity, it's easier to push, as long as obviously the pressure inside is not higher than the pressure in the cavity. But when you have a larger volume, it's easier to push. But you'll get lower pressures. So for conditions where you want higher pressure, you normally have a smaller cavity. This would not be one of those cases. I think this is just trying to get maximum air volume using as many standard components as possible. So they won't have custom made O-rings or seals or anything for this. This will just be standard off the shelf O-ring sizes that they've kind of conformed to. Unlikely that they've gone any further than that. And yeah, so that's basically how it works. So you're just going to be forcing air, so you're going to be allowing air into the cavity and then forcing the air from inside here out and inside there with every stroke. I'm not going to try and work out the volumes of that, I don't think it's necessary. But then the next thing is now, so you created an air cavity here using the wrong color. So this is now all air, pressurized air, which is trying to force all of this water or air to go somewhere. And the cleanest, neatest route for it to go by design is that you are going to be forcing water or whatever is at the bottom. So if this is completely full of air, then you would be forcing air through this gap. But because your only exit area is here in this bottom corner on the to the tube, you're going to be forcing it down up through the pipe and into your trigger mechanism, which is that guy, for a better version of it. And that's where your main seal is going to be. So you've got a seal up here, a seal there between those two components, a seal here, a seal there, and then a seal there. But this is the most mechanically working seal, so that one and this one here. This is the one that we had a look at just now in the bottom inside there, and basically what that's going to do is it works like a normal tap does, except it's spring loaded. You've got a spring at the top here, you've got your interfaces there, and then you've got your lever and a plunger there. And what that happens is the water will gather up here behind this arm, or behind this this interface there. And as soon as you push this lever in like that, that's going to move up. You're going to compress the spring, you're going to move up, which allows this area here to open up. And once that opens, it allows all your water to flow through and spray out on the side there. And with that, you're going to have your nozzle here, which is just quite okay. So that's just got it's got a plastic seal on there, and this nozzle will just allow the direction of the water to change and the flow of the water to change through the spout, and that's what's going to give you either a broad spray or a narrow one with more pressure. So you know, if you're trying to cover a big surface area, obviously you want a broad one. If you're not, then you would go with a narrow one. Anyway, thank you guys very much for watching. I hope you found it interesting. I will try and put some timestamps in the video for you guys to make it a little bit easier. And then, yeah, give us a subscribe and like if you're interested in seeing more content. The next project where this is going, I think, could be quite cool. We're going to bring in some 3D printing and some different components and things like that. And yeah, a lot of people might find it quite useful. I think I certainly think it's going to help me out a lot. So yeah, exciting. Thanks very much for watching.